Good afternoon. I am Amish Agrawal from ECE department. Today we'll talk about virtual memory management in Windows 10. So what is virtual memory? Whenever CPU wants to use data from the main memory, it accesses it in virtual memory address. This address is then mapped to the physical memory address by the operating system. The virtual address space allows the system to simulate more memory than what is physically available. The operating system handles the mapping and other processes related to it using the memory management method. So how does it work? The mapping between the virtual address to the physical address is stored in something called a page table, which are then stored in the disk or the main memory. Windows 10 uses different techniques to manage virtual memory efficiently, which includes demand paging, page replacement, and page aging. Demand paging allows the operating system to load pages only when they are needed, while page replacement algorithms decide which page should be swapped out of RAM when there is no space left. Windows 10 also includes a memory compression feature that reduces the amount of memory that is swapped out of memory disk. This feature can improve system performance by reducing the disk I/O and speeding up page swap. Let us look at what is paging. The virtual address space is divided into equal sized chunks called pages, and similarly, the physical memory is also divided into equal sized chunks called frames. The sizes of frames and pages are equal. Windows 10 supports two page sizes depending on the processor type. In the given table, we can see that one small page size and one large page size. In Windows 10 server version, large page sizes can also be mapped to huge pages of size 1 GB. This is done automatically when allocation size exceeds 1 GB. Now let us look at frame allocation. In Windows 10, it involves assigning frames to the virtual memory pages. Frames are blocks of memory in the physical memory, which are mapped to the pages in virtual memory space. Windows 10 uses different algorithms like first fit algorithm, the best fit algorithm, and the worst fit algorithm. The first fit algorithm selects the first available physical memory frame that is large enough to hold the virtual memory page being allocated. The best fit algorithm searches for the smallest available physical memory frame that is large enough to hold the virtual memory page being allocated. The worst fit algorithm searches for the largest available physical memory frame that is large enough to hold the virtual memory page being allocated. Frame allocation is an important aspect of Windows 10 memory management. It ensures that physical memory is used efficiently and effectively, and it helps to prevent the system from running out of memory. Now let us look at demand paging. It basically means that a page is loaded from the disk into the main memory only when it is requested. This means that for a particular program, which is bigger than the memory space available, is also able to run because at a particular time, it will only use certain processes and require only limited number of pages to be loaded. When an application needs a page which is not present in the main memory, a page fault is generated, which fetches the required page from the disk into the main memory. This is called page swapping or paging. Indirectly, it allows the system to use disk space as an extension of the physical drive. When is generated, required pages need to be placed into the memory. If there is empty space available when it is loaded, then it is loaded without any issues. But if the memory is full, then we will have to replace the existing pages. This is known as page replacement. In Windows 10, uh, the page replacement algorithm is a variation of the least recently used algorithm, or the LRU, which is called the modified least recently used algorithm, MLRU. It takes into account both the time the page was last accessed and whether it was modified or not. When a page fault occurs, the MLRU algorithm selects a list of candidate pages which were not recently accessed and replaces the one which was last modified. If there are no pages which were modified, then the page which has not been accessed for the longest time is replaced. This is an effective page replacement algorithm that takes into account both the recency and the frequency of page accesses, as well as whether the page has been modified or not. Let us look at page age. It keeps track of the time a page has spent in the main memory. Page reference count tracks the number of time the page was accessed, and the page age count tracks the time it has spent in the physical memory. When page replacement is done, an aging score is calculated using the page reference count and the page age count. Page with lower aging score is replaced. This approach ensures that pages that have not been accessed recently or that have been in memory for a long time are more likely to be selected. For replacement, while pages that have been accessed frequently or that have been in memory for a short time are more likely to be kept in memory. Now, let us look at some advantages of virtual memory management. The first, increased available memory. The OS can simulate and run large programs even when there isn't sufficient physical memory available. This is achieved by swapping pages of memory between physical memory and disk storage, allowing more processes to be run concurrently and reducing the likelihood of memory exhaustion. Second, improved multitasking. Virtual memory management allows multiple processes to run together, each with its own private address space. This means that the process cannot interfere with another process's memory, leading to improved stability and reliability. Additionally, virtual memory management allows the operating system to allocate memory more efficiently, minimizing the impact of one process on the performance of another. Third, better memory utilization. It enables the operating system to utilize the physical memory resources available on the system efficiently. By swapping out pages that are not actively used, the operating system can free up physical memory for other processes that need it. This can lead to improved overall system performance as more memory is available to run applications. Thank you.